So beware of this particular integral. They asked it today. And so the same format, just reversing the thingy. So by the same logic again, if we were to integrate cos squared x sine cubed x dx, in this case you'd say cos squared x sine x into sine squared x, and integral of cos squared sine into 1 minus cos squared x. So this opens into cos squared x sine x minus cos 4x cosine raised to 4x sine of x dx. And so again, conveniently, the derivative of cosine is negative sign, and in this case we have those here, or at least yeah. So in this case my constant adjustment will give me negative 1 over 3 cosine cubed x plus 1 over 5 cosine raised to 5 of x plus c. Again, if you're wondering how I'm getting these constants, use the same method of reverse chain rule. So yeah, you'll notice this general trend in these questions. We are decomposing in when we had sine cubed cosine squared x, and when we had sine squared cosine cubed x, the cube function we are decomposing into power 1 of it and then a square of it, and then that square we're expressing in terms of 1 minus the other elementary trig function squared. So sine squared, we represented it as cos squared, and in this case we decompose that cos cubed into cos squared, and then that cos squared we represented as 1 minus sine squared. So yeah, and then it worked out as you saw. We opened up the brackets and we had two reverse chain rule terms, two very convenient reverse chain rule terms. So yeah, just keep that in mind. When you have such a function of this type, the square term stays. The cube term, you decompose it into power 1 and power 2, and that power 2 you express it as 1 minus the other trig function squared. So cos squared, you will yeah, you get it. So yeah, beware of this integral as well alongside sine cubed and cos cubed integrals. Thank you.